Hi everyone. In this video, we are going to discuss about regular polygon. We'll see how to find the area of a regular polygon, and also we are going to see how to find the inradius and the circumradius of a regular polygon. Let's suppose we have a regular polygon of n sides like this. In fact, in this diagram you are seeing a hexagon, but let's assume that it is a regular polygon of n sides. Let's assume that it has n number of sides, right? And each side will be of equal length since it is a regular polygon. Each of the interior angles will also be equal in size because it's a regular polygon. That's the property of regular polygon, that each side will be equal length and each interior angle will be of equal size. Now let's suppose the pink dot is the center of this regular polygon. I have joined the center to two of the adjacent vertices. Also I have drawn a perpendicular from the center onto that side, and I have assigned a name to each of those points there. The center is O and one of the vertices is A and the next one is B, and let's also assume the foot of perpendicular to be P. I am denoting the circumradius with an uppercase R and the inradius with a lowercase r. Now if you are thinking how would the circumcircle look like and the incircle look like, well, the circumcircle is going to look like this, the yellow dotted circle that I have in the diagram, and the incircle is going to look like the pink dotted circle in the diagram. So OP will be the radius of the incircle, and OA or OB, that will be the radius of the circumcircle. And here I have made a few additional notes. The side lengths are equal because you are talking about a regular polygon. The side lengths will be equal. Also the interior angles are equal. That means each of the interior angles will be of equal size. And let's assume that the number of sides is equal to n. And also let's assume that the side length is A. And in the diagram, the length of AB line segment will be equal to A. That's one of the sides of the regular polygon. And as per the drawing, OP is perpendicular to AB. This perpendicular will divide the triangle OAB into two congruent triangles. So AP and PB, they will be of equal size and each of them will be half of A. And OA is the circumradius and OP is the inradius. Also, what will be the size of the angle AOB? Well, it will be 2 pi over n because the entire angle around the center is 2 pi radian, and because we have n sides here, so each of these angles at the center will be of equal size and each of them will be 2 pi over n. So angle AOB will be 2 pi over n. And then what will be the size of angle AOP or angle POB? Well, it will be half of the angle AOB. So that will be 2 pi over n divided by 2, which will be equal to pi over n. So I have denoted that angle AOP will be equal to angle POB and each of them will be equal to pi over n. Also we know that for a regular polygon, the sum of interior angles would be equal to n minus 2 times pi. And if you are thinking about the size of each interior angle, it will be n minus 2 times pi whole divided by n. Next we are going to try and calculate the size of the circumradius and the inradius. Now if we look at the triangle AOP, what would be the sign of angle AOP? Well, it will be opposite over hypotenuse, that will be AP over OA. Now what is the size of the angle AOP? Well, it is actually pi over n. So we can say sine of pi over n is equal to AP. What is AP? Well, AP is half of A over OA. What is OA? Well, OA is actually the circumradius, uppercase R, and from here we can say that R will be equal to half of A times cosecant of pi over n, and I am going to highlight that. Next we are going to calculate the size of the inradius. In the same triangle, let's now take a tangent ratio of the angle AOP. That will be opposite over adjacent, which is AP over OP. Now angle AOP is actually pi over n, so this will be tangent of pi over n is equal to AP. Now what is AP? Well, AP is actually half of A over what is OP? Well, OP is the inradius, which is lowercase r, and from here we can say that the inradius, the lowercase r, is equal to half of A times cotangent of pi over n, and let me highlight that too. Let me find out the value of the side length in terms of the circumradius and the inradius. We just saw that the circumradius is equal to half of A times cosecant of pi over n, and from here what will be the value of A? Well, A will be equal to 2 times r times sine of pi over n. And similarly, let's try to find out the value of a in terms of the inradius. We just saw that lowercase r, which is the inradius, that is equal to half of a times cotangent of pi over n, and from here we can say then a will be equal to 2 times r, the lowercase r, times tangent of pi over n. Next we are going to see how to calculate the area of the regular polygon. Now the area of the polygon will be n times the area of the triangle AOB, because there will be n number of triangles like that inside this regular polygon. Each of the triangles will be of equal area. So if you consider triangle AOB, its area multiplied by n will give us the area of the entire regular polygon. So now I am going to say area of the polygon is equal to n times the area of the triangle AOB. Now what is the area of the triangle AOB? The area of the triangle AOB would be half times AB times OP, assuming AB to be the base and OP to be the height. So it would be half times AB times OP, and this can be written as n times half times AB. Now what is AB? Well, AB is the side length, which is lowercase a. And what is OP? Well, OP is the inradius, which is lowercase r, and this can be written as half times n times a times, what is the value of the inradius in terms of a? Well, it is half of a times cotangent of pi over n, and this is equal to 1/4 times n times a square times cotangent of pi over n. So when the side length is provided for a regular polygon, we can calculate the area using this formula. Area will be equal to 1/4 of n times a square times cotangent of pi over n. Now I am going to use the value of a in terms of the circumradius, and let's see what is the area then. So let me first write it down again. Area is equal to area of the regular polygon, of course. Area is equal to 1/4 times n times a square times cotangent of pi over n, and here in place of a I am going to use the value which is 2r times sine of pi over n. So then we can say this is equal to 1/4 times n times, in place of a I am going to write 2r the circumradius times sine of pi over n whole squared, because we had a squared. So in place of a squared I am just writing 2 times r times sine of pi over n whole squared times cotangent of pi over n, and from here we are going to get 1/4 times n times, this should be 4 times r square times sine squared of pi over n times cotangent of pi over n can be written as cosine of pi over n over sine of pi over n, and here you see the sine of pi over n in the denominator will cancel one of the sine of pi over n in the numerator. So we are going to be left with n times r squared times sine of pi over n times cosine of pi over n, and to make it a little more easier we can multiply and divide by a 2 here. So we can say this is equal to half times n times r squared times 2 times of sine of pi over n times cosine of pi over n, and as you can see this will convert into half times n times r squared. Within the parenthesis what we have, this is actually sine of 2 times pi over n. So that is the area of the regular polygon in terms of the circumradius. Also, let's try to find out the area in terms of the inradius. The original formula for the area was 1/4 times n times a squared times cotangent of pi over n, and wherever we have a, I am going to use 2 times r times tangent of pi over n. That's the value of a in terms of the inradius that you can see in the yellow box up there. So here I am going to write it as 1/4 times n times, wherever we have the a, I am going to write 2r, which is the inradius, the lowercase r, times tangent of pi over n whole squared, that is the a squared, and then also we have a cotangent of pi over n, and this is going to be equal to 1/4 times n times 4r squared times tangent squared of pi over n times cotangent of pi over n. So one of the tangent of pi over n multiplied by cotangent of pi over n, that will become 1. So we are going to be left with just 1 tangent of pi over n. Also the 4 in the denominator and the 4 in the numerator, they will cancel out each other. So we are going to be left with n times r squared times tangent of pi over n, and let me highlight that as well. So we have been able to find the formula for the area of the regular polygon in terms of the side length, in terms of the circumradius, and in terms of the inradius. And also if we are provided with the circumradius or inradius, we have derived the formula to find out the side length And similarly, when we are provided with the side length, we can also derive the circumradius and the inradius. The formula for the circumradius and the inradius, they are up there in the pink box, and then formula for the side length in terms of circumradius and in terms of inradius, they are in the yellow box. And then down here we have the formula for the area of the regular polygon in terms of the side length and in terms of the circumradius and in terms of the inradius. Now I'm going to use the area formula for a couple of interesting regular polygons as an example. So suppose we have a square. A square is a regular polygon, each side length is equal and it has 4 sides of course. So for a square, what would be the area then? Well, let's see. So I'm taking an example where I'm saying that the regular polygon is a square having the side length equals a units. Now because it is a square, what would be the number of sides? Well, n will be equal to 4 and the side length is actually a. Now what would be the area of the square? Well, let's use the first formula for the area of the regular polygon, which is 1 over 4 times n times a square times cotangent of pi over n. So let's use that and see what happens. Here I have noted the area formula. Now I am going to plug in 4 in place of n and let's see what happens. So it will be 1 over 4 times, I am writing 4 in place of n and then a square and then cotangent of pi over 4 in place of n I am writing 4. Now cotangent of pi over 4 is actually equal to 1 and then you see this 4 and this other 4, they will cancel out each other. So we are going to be left with just a square, and that's exactly correct because we know that the area of a square is the square of its side length, which is in this case a square. So our area formula works for a square. Now let's try to use it for an equilateral triangle. So here I have noted the second example where the regular polygon is an equilateral triangle, and let's assume that its side length is a. Then what would be the area of this regular polygon, which is actually the equilateral triangle? Well, in this case number of sides would be 3. So n is equal to 3 and the side length is a. Now let's calculate the area. The original formula for the area of a regular polygon is like 1 over 4 times n times a square times cotangent of pi over n, and here I am going to replace n by 3 because in this case n is equal to 3, so I am going to write it as 1 over 4 times 3 times a square times cotangent of pi over 3. Now what is the value of cotangent of pi over 3? Well, that is actually cosine of pi over 3 over sine of pi over 3. Now pi over 3 is 60 degrees, so cosine of 60 degree over sine of 60 degree, that will be equal to 1/2 divided by root 3 over 2, and that will be equal to 1 over square root of 3. So then this can be written as 3 over 4 times a square times 1 over square root of 3, and that will be equal to square root of 3 over 4 times a square. And that seems to be accurate because we know that the area of an equilateral triangle is actually square root of 3 over 4 times a square. So in both the examples, looks like our area formula is working just fine, and in fact that is the correct formula for the area of a regular polygon. And once you have this formula, no matter which value is provided to you, you should be able to derive the other value. Like if you are provided with the side length and the number of sides, then you should be able to calculate the area. If you are provided with the circumradius and the number of sides, then you should be able to calculate the area. And similarly, if you are provided with the inradius and the number of sides, then also you should be able to calculate the area of the regular polygon. And if you are provided with the side length and the number of sides, you should be able to calculate the size of the circumradius as well as the size of the inradius. I hope everything made sense. Thank you for watching. See you in the next video.